students, welcome back to Best Academy. Today I'm going to discuss new topic, that is last topic adding new example how you can prove a transformation, whether the transformation is linear or not. Last time I have choose R2 to R2 space. Today is the transformation is Pn to Pn minus 1 R term and is defined by T f of x equal to f prime of x. Here f prime of x denotes a derivative term and it is to show that T is linear. To obtain this type of transformation is linear, we already know the definition of transformation, that is T of x plus T of y is equal to T of x plus T of y term. Let's start today's lecture and try to understand how you can prove it. So the first side of an expression we choose here is let g of x, h of x belongs to Pn or. The reason is that here we have defined function type transformation. So we choose function type of the value which related to this polynomial functions, right? So the first property is related to that is t into g of x plus h of x, right? So the obtained thing is that this is basically your left hand side of an expression, right? So the first side is that when you're going to apply the transformation, the function is plug in the values, we will obtain the derivative. So we can written as this g of x plus h of x whole time derivative. This is the notation of derivative term, right? So now you can give the values in separate way, that is g prime of x plus h prime of x. So this is the notation you have obtained your left side of an expression. Now we choose on your right side of an expression and check this is the whether the left side of the expression is equal to right side of an expression is equal or not. Now we choose the left side, that is right side of an expression. Choose that is t into g of x plus t into h of x, right? So if you notice that we are going to apply the transformation t to g of x, the function have the value with derivative terms. So we can written as this term, that is g prime of x, right? So this term is going to look like you're going to plug the values, that is h prime of x, the remaining values. So left hand side is equal to right hand side. So this is your first property. This is your first property, that is which is satisfied. Now we choose second property, right? So how you can prove the second property is linear or not? So we choose let c is basically a scalar term. So the second property is that if you're going to apply the term, that is c into g of x term, right? So when you apply this transformation on scalar out of your term, so that is c, this is your basically left hand side, so c into t into g of x. Basically when you t is basically an operator, when you whenever you want to apply the operator, t scalar outward term and t separate will be applied. So we have obtained c into g prime of x term, right? So this is your left side of an expression with 10c into g prime of x. Now we choose your left side, that is right hand side. Right hand side. Now we choose right hand side, that is c into, that is related to c into t of x. So here, here is, that is t into g of x term. So if you're going to apply the same function, that is c into g prime of x. If you notice that here is your left side of an expression is equal to right side of an expression. So we can say that this transformation left hand side is equal to right hand side of an expression. 1 and 2 satisfied. So the given transformation, is linear. So this is the basic procedural way you can prove any transformation is linear or not. This is the polynomial type. The first explanation was R2 to R2 space. Similarly, you can choose any example, let's say Rn to Rn, R3 to Rn, this type of. Here I'm going to just start my lecture. If you have any sort of query, any sort of question, give me a comment. I will discuss in next video. See you shortly till next video. Bye bye.